So helicopter problem. Here we have a helicopter, and the upward force on it is going to be the force of the air on the propeller. And that is a normal force. The propeller pushes down on the air,
Right.
and the air pushes up with an equal and opposite force. It's actually an example of Newton's third law. And then, of course, we have the usual downward force from the Earth, which is mg. And right now I've drawn Fn bigger because without any load it accelerates up, which tells us there must be a net force up.
Right.
Let's make up positive. So the net force, and I'll just put in the y direction, is going to be Fn from the air pushing up on the propeller minus its weight. Okay? And then we apply Newton's second law, so ma equals that. So I want you guys to do this procedure that I explained to you, almost even before you read the question, what the question is asking. It makes sense to just set this all up, because that's going to be true no matter what the helicopter is doing.
That's just for the helicopter without a load.
Correct.
Okay.
Well, that's true with the helicopter with a load or without a load. It's just the only thing without the load, the Fn is going to be bigger than the mg. So this is going to be true with or without a load. So let's do the without a load part first. So we're told the mass is 3770, so we put that into mass here and there. Oops, there. We're told the acceleration is 1.34. See, we're just plugging in numbers now. Once we set that net force equation up, we're golden. And we know g is 9.8, and so we've set up this net force equation. This is the whole goal in all this physics, particularly in this chapter. Once we have that, we've just plugged in numbers, and what are we solving for? We're solving for the force normal of the air on the propeller, which is going to be the same. The maximum force is going to be the same whether there's a load or not. It can just do what it can do. You're live.
Could you also just do net force equals mass times acceleration?
Yes, and that would give you the net force just in the first circumstance, though.
So that's not as useful.
You could use it. You could do it that way. I'm just trying to show you like a every single time way it'll work every time.
Okay.
So yeah, you could do that. That would be the net force, and then you could set that equal to the added weight of the cargo and do it that way. So you just set ma equal to the new mg with,
So
it would be the weight of the cargo would equal that disparity in weight and normal force. You can do it that way. But if we continue doing this way, so that equals 41,997 newtons. That is the lift force. That's this Fn. That's going to be the same whether there's a load or not. Okay. So now if we put a load on there, what changes? So what's going to change, this equation stays the same. What's going to change is the mass. So we're going to have the mass of the helicopter plus the mass of the cargo now times the acceleration. We're just kind of rejiggering this equation equals that same force normal. So we'll just write in 41,997 newtons. Plus those same two masses. It's a new weight, right? So it's going to be m of the helicopter plus the m of the cargo times g, which is 9.8, right? So now I just plug in, this is 3770. This is 3770. We know g is 9.8. Now the acceleration, if it is just to lift off the ground, is 0, right? Just if it's hovering. Before there was a net acceleration up. Now with this cargo that's overloaded, there's no acceleration. So everything equates out. And so what's going to happen is this upward thrust, this force normal on the propeller, is going to end up equaling the new weight. So this minus 41.9, that should have been a minus sign here. We need to change that. It should be minus, not plus. Minus that is going to equal minus 3770 of the helicopter plus the mass of this new cargo times 9.8, and then you just solve that for the mass of the cargo. And I think it comes out to like 515 kilograms.
Yeah.
Which you could have done the way that you described.
Well,
so you could have set ma, the net force, earlier, ended up being 5,000 something, you could have set that equal to mg of the cargo, because right, you keep adding more and more cargo. That
Right.
weight of that cargo at some point equals out the net force, the difference.
Makes it 0.
Yeah.
So